A student last week that asked, that only gives us how we find the surface area of things that have flat faces. Are we going to learn about curved faces? That's today. So you need three formulae. Cylinders, cones, and spheres. I don't know why I wrote sphere again up the top. That's stupid. So cylinder, where does that formula come from? Well, a cylinder is two circles, one on each end. That's where the 2 pi r squared comes from. And 2 pi r d, what's special about a cylinder? The thing that wraps around a cylinder, is a rectangle. Okay? Because if I wrap this around, that forms the outside of a cylinder, does it not? Okay? And what's special about the length of that rectangle? It's exactly the circumference of a circle. Okay? So this formula here, this part of the cylinder formula here, 2 pi r, if you remember from previous years, 2 pi r is the circumference of a circle, and you're timesing it by d, which is the depth of the cylinder. The cylinder is that deep, that tall. So what is the formula of a cylinder? It's 2 circles plus the area of a rectangle that is exactly the circumference of a circle times by how deep it is. Can you get that down, please? So I was looking for a pair of scissors. The demo for the cone might not be the best. I'll try my best anyway. The area of a cone. What is on the bottom of a cone? A circle, so pi r squared. Anyone know what, if I flattened out the cone shape at the top, what would it be? Would it be a circle as well? Any thoughts? You don't have to know. I'll try to make a circle here. I wish I had a pair of scissors. This is the lamest circle. So for people on the YouTube video, I'm currently ripping a circle out of paper. Let's pretend that was a circle. It's sort of an oval shape, right? If it was just like this, it's not three-dimensional. It's just flat on the ground. But if I cut to the center, sort of like a pizza slice shape out of it, so now it looks like Pac-Man, that's going to make it 3D into a cone shape. Okay? So the thing on top of a cone actually looks like this. It's like a circle, but it's got a slice cut out of it, and the area of that is pi times r times by s. So s is that. S is the diagonal or the sort of slant. That's why it's called s. It's called the slant of the cone. And obviously, if you need to find the slant, you would use Pythagoras. If you weren't told s, you'd use Pythagoras to find them, because that's the hypotenuse of the right angle triangle that goes to the center of the cone. Okay. So surface area of a cone, pi r squared, circle on the bottom, plus pi r s. And then lastly, we discussed last week, what is the surface area of a sphere? I don't know the explanation for why this is, but the surface area of a sphere is literally 4 circles. 4 pi r squared. Can you get those 3 down, please? Because we're going to use them next, and you're going to hammer those in your assignment. It looks like you'll start your assignment next Wednesday. It'll go into the holidays, but I don't want you to use the holidays to do it, okay? Just chill out in your holiday. It's a holiday. You'll have plenty of time in class to work on the assignment. So you got those 3 formula there. Find the exposed surface area of the object below. So what shapes do we have in this object? Sphere, cone, cylinder, those shapes that I just gave you. Are all surfaces going to be exposed in this? No? you got a couple of circles that should be hidden there because the cone and the cylinder are joined. So we need to consider taking those away after, because the formula that I've given you just give you the full surface area. So let's find the surface area of the sphere at the top. SA sphere equals 4 times by pi times by. Does the sphere tell me the radius of it? So if someone died in here, does it tell me the radius of it, or does it tell me the diameter? It tells me the diameter, so the radius would be what? Half of that, so it would be 4 times by pi times by radius squared. Calculator. 4 times by pi times by 3 to the power of 2. You're going to have 113.10 square centimeters rounded to 2 decimal points. That's our sphere. That's the sphere done. Surface area of cone. What do we have? Pi times by. What's the radius of the cone going to be? Are you told that directly? You make assumptions that everything is straight and tall. So what should the radius of the cone be? 3. Pi times by 3 squared. We've got the circle on the bottom, plus pi times by the radius again, which is 3, times by... Our problem is we don't have S. We know how tall that cone is. We know how wide it is across there. But do we know the slant height? No. What guide do we use? Pythagoras. So you bring it down to the middle. That's going to form a right angled triangle. Half of that's going to be 3. So it's going to be 3 by 8. So S, let's call that S. S squared is going to be 3 squared plus 8 squared. That's going to be 9 plus 64. What's that? 73? So S is going to be the square root of 73. So it's not going to be a nice number at all. But that's what the diagram was that I drew. Square root 73. It's like 8.54 centimeters. So now do I have my S? 8.54. So the Apple calculator's improved since the previous version. So pi times by 3 squared plus pi times by 3 times by 8.54. So we have 108.76 square centimeters. That's to 2 decimal points as well. So notice that I'm finding the full surface area. Don't subtract anything just yet. I'm only asking you to do that. I'm only demonstrating that because when you start your assignment, I've got a spreadsheet set up so that when you design your thing that you're going to find the surface area of, it's going to be easier for me to mark it if you just find the full surface area of everything and subtract things to take away separately. Don't try to do it all in one, okay? And then lastly, cylinder, surface area of the cylinder, pi times by. What's the radius of the cylinder going to be? 3 squared. But there's 2 of those, so 2 times by pi, because there's 2 circles, plus 2 times by pi times by r, which is 3 times by the depth of it. I haven't given you a depth of that. Let's just say that it was 8 again, because it looks about the same. So let's say it was 8. So lastly, 2 times by pi times by 3 squared, plus 2 times pi times 3 times 8, 207.35 square centimeters to 2 decimal points. So right now we have a total Has anyone heard the term gross? Not gross as in it's disgusting, but in money and stuff. When we say gross, it's like the total, ignoring anything taken away. So you could also call it gross. Surface area is going to be the 113.10 plus 108.76 plus 207.35. 113.1 plus 108.76 plus 207.35. That's the full surface area. If we were ignoring the fact that there's parts touching, what do I need to subtract to get the exposed surface area only? How many circles do you reckon I need to take away from this? I would say 2. Whenever there's something touching, there's 2 touches, not just one. Because it's the bottom of the cone and it's also the top of the cylinder. I think maybe you said 3 because, the bottom of it, let's pretend it was sitting on the thing, that's fine. You could do that. In your assignment, you could say that, but for our purposes, they're joined. So we just need to take 2 circles off. So unexposed is going to be 2 times by, what's the area of a circle? Pi times by the radius squared, which is 3 squared. 2 times pi times 3 squared. So we just need to take 56.55 square centimeters off of that. So net SA exposed is going to be your 429.21 minus 56.55. 429.21 minus 56.55. 372.66 square centimeters. Okay? That's the process of that. It's laborious, that's fine. That's why I'm demoing. I'm showing you how it's done. You can get quicker as you improve at that.